the flick of a switch. That's how easy it is to get electricity, right? If you are one of the lucky ones, then yes. But even today, there are still over 1 billion people who do not have access to electricity. In this video, we will discuss how electricity is generated and transferred to our homes for those of us fortunate enough to have it. There are a variety of ways in which electricity is generated or made. How many can you think of? Solar panels, wind turbines, biomass, hydroelectric, nuclear and fossil fuels, and then there is also geothermal energy, tidal power and wave power as well. Except for burning fossil fuels and nuclear, the rest are renewable sources of energy. Currently, about 80% of the world's energy comes from fossil fuels. First, we are going to have a look at burning fossil fuels in power stations to generate energy, and then we'll look at the national grid, which is relevant for both non-renewable and renewable energies. Fossil fuels in power stations. Most power stations uses coal as energy source, and they work in the following way. Coal is burnt in a power station. The heat produced as the coal burns is used to heat water. The water boils and turns into steam. The steam is used to turn the blades of a turbine. A turbine looks like a fan or a wind turbine. The turbine turns a generator. Inside, wires turn within magnets to generate electricity. So that was a fossil fuel power station. These next steps are for energy generated from any source, whether it is fossil fuels or renewable like wind-powered substations or biomass-fueled. The electricity, whether renewable or not, is passed through transformers and wires within the national grid that carries it to our homes. So what exactly is the national grid? The national grid is a system of cables and transformers linking power stations to consumers. Have you ever felt an electrical wire and noticed it gets hot? This is because some energy traveling through the wire is lost as heat. In order to lose as little energy as possible, transformers are used. When the electricity leaves the power station, it passes through a step-up transformer power station at 25,000 volts. A step-up transformer increases the voltage and reduces the current. National grid cables at 275,000 volts. Reducing the current makes the transfer of electricity more efficient as energy is lost as heat. Before the electricity gets to our home, the voltage needs to be reduced back down to a safe level. The electricity therefore passes through a step-down transformer household at 230 volts. So now you know how electricity is generated and sent to our homes. It is not quite as simple as flicking a switch. Quite a lot of infrastructure is needed.